Hi guys, I'm Eddie. Today we are going to look also on the other part of low-hanging fruits. But on this one, I'm just going to focus more on formulas and substitution, right? This is another area where you can also easily collect some easy marks on formulas and substitution, right? But there are some top hints when you are busy with your calculations that you need to take into consideration. We've got also an Excel video on REF1, which simply means you should be in a position to clearly read your question, extract some information from it, choose the correct formula from the given formula sheet, do some working on it, that is your substitution, then give the correct answer with the correct unit. Remember, we are dealing with physical quantities when you are in physics, right? Let's have an example. We have got a question. Here's a question where we should be in a position to see when are we using formulas and when should we do substitution, right? There is a question on projectiles. If you check on question 3.2, it's actually saying calculate. When you're supposed to calculate, that is the height of the building. Now let's have a look on it so that we'll go through it together. We need to calculate the height of the building, right? Please make sure you're in a position to know what are you required to calculate so that you don't need to mix up your things. So this is how it goes. Fine, I'm writing down my information. I'm supposed to calculate the height. Now I want to calculate my height. That is delta x or delta y. It simply means the same thing. That is what we are required to calculate, right? What other information do I have? Please guys, you know that always in projectiles you have acceleration. So your acceleration is always downwards, which means it's minus 9.8 meters per square second. Please don't always forget to make it negative 9.8 meters per second. Why? Because we are going to choose our direction as upward as always positive. This makes our life easier. So since acceleration is always downwards, so you must always make sure that you make it negative throughout your calculations so that we avoid some silly errors, right? Let's move on. What other information is given? The ball hits the ground after 3 seconds, right? If the ball hits the ground after 3 seconds, so it means our time is also 3 seconds, right? What other information can you get out from the question? A ball has been projected vertical upwards with a speed of 10 meters per second. That is another information that is given. So our initial velocity is also equal to plus 10 since our ball is moving upwards. So it's plus 10 meters per second. We should get used to our units because they're very important, right? Let's check what other information is getting there that we can extract from the paragraph, which will help us to choose our formula, right? Now we have got this information. Let's see from our equations of motion which one of the equations here will be the most appropriate one for us to use. Remember, we are supposed to calculate our height, that is delta x or delta y. So let's have a look on our equations. Which one of the equations is having delta x or delta y? This one has it. Also, this one is having it, as well as this one, right? Let's choose amongst the three which one will be the best. Fine. All these have got delta x, right? The next thing that we need to choose, let's see which one is having t, because remember almost all of them have got acceleration, but there is this one which doesn't have acceleration. So we need to check an equation which is having t, time. This one doesn't have time. Fine. This one is having time, where that is our time there. The same applies as this one. It also have time. Right. Let's see another quantity which is also present. Like in this case, we have got our initial velocity. This one has initial velocity as well. That is enough initial velocity. This one has initial velocity, but now this one did not have time, but we've got time there. This one also includes final velocity. We don't have final velocity there. We only have initial velocity. This one also requires us to have final velocity, and we don't have final velocity here. So that leads us to say our best equation is this one. Now, after choosing your best equation, you need to write down your equation so that you get the first mark for copying the formula correctly from the formula sheet. So in this case now, we are going to say 3.2.1. Then you copy the formula as it is. Delta x is equal to VI delta t. Don't worry about the delta. It just shows that there's a change in time. So our change in time is already 3 seconds plus half a delta t squared. Now, life is easy for us since this is the information that is guide us to choose the equation. Now we do substitution. Delta x is equal to our initial velocity, that is 10, and our time is 3, then plus half. Our acceleration, don't forget acceleration is negative, that is 9.8. Then there we go, we multiply by our time, which is 3, then we square it. Then from here, it's not easy. You can now punch this into your calculator. All right, let's have a look on another question again. Still on the same question on projectile, let's look at 3.2. We want to calculate the speed with which the ball hits the ground, meaning we want the speed of the ball here as it is falling. Right. Let's write down the information again. What are we required to calculate? We should calculate our speed. Sorry, let me clear off this for you guys. Right. We need to calculate our speed. So speed is v, but speed with which the ball hits the ground, so in this case is our final velocity. This is what we want to calculate. Right. What other information do we have? We always know that we have got acceleration, which is equal to negative 9.8 meters per square second. Right. What else do we have here? Our initial velocity, that is v initial, that is equal to plus 10 meters per second. Right. What other information are we having here? If we look into this, still our time, all this information, this is our initial velocity, that is the time. Our A is always known. Then I'm writing down the time now, that is 3 seconds. Right. Let's have a look on the formula. This is from the formula sheet. The best equation now, we want an equation that we can calculate V final. This equation here is V final. There is also V final. There is also V final on that one. Right. Which other physical quantity do we have? There is acceleration, which is our acceleration. This one is acceleration as well. There is acceleration as well. There is acceleration. Right. But since this one doesn't have the quantity we are supposed to calculate V final, so this one already is out. Right. So these two equations both have acceleration, both have got our quantity which we want to calculate, that is the V final. So there we go. Now we need V initial. Which one of these equations again is having V initial? This one has initial velocity. This is also having initial velocity. Now, those are our quantities. V initial, we have our time. There is time here. There is time here. We have time. Now, this is time. Which equation has time? this one is having time. Unfortunately now, there is no time in this one. There is no time in this one. Fine. But there is another unknown in this equation, which is this delta x. But we don't have our delta x here. So this makes this equation the correct equation to choose. Now we have seen that this is our correct equation. You need to copy it down as it is onto your answer book. That is question 3.2.2. Our correct formula will be VF is equal to VI plus A delta T. Now we do our substitution. We need to calculate V final, V initial, that is 10, plus acceleration should always be negative 9.8. Then we multiply by our change in time, which is equal to 3. Then you enter this information into your calculator. Just as simple as that. Then you out of 3 already for choosing the formula correctly plus correct substitution. You're having your 2 marks, right? Let's have a look on another question again, still on the very same topic of projectiles, right? Here is the question, which is 3.2.3, right? What are we required to calculate? Speed with which the ball leaves the ground. On 3.2.3, we can see that this is now the second motion of the ball after it has hit the ground. Now it has bounced off back into the air. So let's see, what information do you know about the second motion of the ball after it has hit the ground, which is now this motion of the ball? That is the one that we want. The first one, it was this one when the ball was falling. Now the second motion is when the ball is rising from the ground after the first bounce, right? What information do we have here? We are supposed to calculate our V initial. That is what we are expected to calculate. Then the information that we can get, we know that acceleration is always downwards. So it's negative 9.8 meters per square second downwards. That's why we're making it negative, because we've chosen our upward as positive. We should not forget about this, right? The other information that we have, we are given our displacement, which is our delta x, that is equal to 8 meters, right? We also need to know that the maximum height, at maximum height, our V final, or the velocity of an object at maximum height, is equal to 0 meters per second, right? Having this information here, we can still now going to choose the correct formula that we need from our formula sheet. Let's have a look. We need to calculate V initial. That is what we need to calculate. We need to calculate V initial. So at the moment, you might take all of them. A, we need our acceleration. That is acceleration. There is acceleration. There is acceleration. There is acceleration. There is no acceleration here. Fine. We now check, that's acceleration. We now check displacement. That is 8. So this one has displacement. This one doesn't have displacement. There is no displacement here. On this one, there is displacement there. On this one, there is displacement there. So we are remaining with 3 of the formula. Then let's now check the other quantity here, which is now our V final. This one is out already because it doesn't have displacement. This one, there is V final, so it qualifies. This one, no V final. This one, it is having V final, like that. Fine. Now, so we are going to remain with 2. This one is out because there is no V final. This is V final. Now, this one, it's giving us everything that we need. But on this one, we still don't have time. So that also rules this one out because it's having another unknown, which is time. So we are going to choose this as our correct formula. Now we are writing it down so that we score our marks. V final I'm copying the formula down. V initial squared plus 2a delta x. Right. I'm now substituting. V final is 0. I have my 0 there. V initial, that is what we are supposed to calculate, plus 2. Acceleration must always be negative because it's downwards. Multiplied by 9.8, multiplied by the displacement which is given, that is 8. Right. Then we have our substitution like that. Now you can rearrange this and you enter into your calculator and get the marks. So already for doing this, you are going to get your 2 marks out of 3 for formula and your substitution. Right. Let's move on. This is another question which is on work, energy, and power, which many people presume or predict that is difficult. Yet it's not difficult. It's still in the same manner that you need to identify what is it that you are given. Right. Let's have a look at this one. Earlier on in the earlier video, we spoke about stating the laws in words. Now in this case, after stating the law in words, the next question is saying calculate using energy principles. There's a simple guideline that, guys, I want you to have. If we have, let's have a little closer look at the question. If you are having a law after stating the law in words, then the next question is saying calculate using a principle. Using a principle. Work energy is an energy principle. So it means now we should go on our formula sheet. When you go on the formula sheet, that is here, it's clarify work energy. That is the section of the formula sheet that we need. Right. Which one of these principles should we use? We are going to get the work energy theorem. That is the energy principle. If we go around your formula sheet, you'll see that that is our work energy theorem. So just writing down the work energy theorem, you are answering the question because you are ensuring that that is the work energy theorem. Right. Then from there, these questions are so nice and easy. We have been required to draw a labeled free body diagram. Let me sketch my free body diagram quickly for you guys. Right, that is the free body diagram. Then we have got our weight. We had also our friction and of course the normal force, which does no work. So the only two forces that we are remaining with is friction and work, though their formula is not that clear. So it's work done by friction plus work done due to force of gravity. That will give us the network is equal to change in kinetic energy. It simply means final kinetic energy minus initial kinetic energy. That gives us our change in kinetic energy. Right. The formula for calculating work is given here in the formula sheet, which is this. Right. So if it is work done by friction, it means where there's an F, we put the magnitude of friction. Right. So in this case, I'm rewriting this formula because we know we should all show our formula so that we get marks. So now I'm saying work done by friction. Friction is small letter f, delta x, that is the formula that is given, cos of theta. Then work done by force of gravity. We know that force of gravity is always given by mg. Then we have our delta x, then cos of theta again. Okay, fine. Allow me to write delta k to represent change in kinetic energy. Fine. I now need to do my substitution. In the question there, I'm given the magnitude of friction, that is 50. So I'm writing my 50. You are given the magnitude of displacement, which is 25. So you substitute 25 like that. And then cos of theta. The object is moving down. Frictional force goes that way. So the angle between the two is 180. So I put 180 on theta. Then here, the mass of the object or the boy is 60. So I substitute 60. We know that G is always 9.8. And the displacement, that is displacement 25. You put 25. Then cos of your theta. This object is moving down and our force of gravity is always downwards like this, so the angle between the two is this one. Since we know this is 20, this is 90, so our angle, this angle becomes 70 degrees, so we have our cos of 70 degrees. Right. Once you have done this substitution here, you've done this substitution, the larger chunk of the marks are coming from that substitution there. Now, I'm taking this side of delta K. Delta K, I've indicated that delta K is equal to half mv squared final minus half mv squared initial. Still, we need to do our substitution here. The mass of the object is 60. I put 60 here. We are required to calculate the initial velocity. The final velocity is provided, velocity at q, which means velocity here is given as 15. So we square it minus half. Mass of the boy is 60. V initial is what we want to calculate. Right. So that gives us the other part of the question, which is this one. Right. So now after doing your substitution like that, it means you are sorted when you have things like that. So now this is now from there. Let's move on to the next question, which is 5.4. The next question, which is 5.4. Fine. This one is far much easier. 5.4. It's so easy. On 5.4, what we need to do is, let's have our formula sheet. From the formula sheet, that is by formula sheet. Right, on the formula sheet, it's saying we are supposed to check still under work, energy and power, but here the question is saying calculate the average power. On our formula sheet, it is there P average. There's only one question which is talking about P average. Our P average is equal to force, that is force multiplied by velocity. So now I'm writing down the formula. Let me write down the formula for you guys. That is P average is equal to F multiplied by average velocity, right? Then from there, F, for us to get an average of two numbers, we are now saying final velocity plus initial velocity over 2 to give us an average of two numbers. Then our force, which is doing this power, which is giving us this power, is friction. Yeah. Now our force of friction is 50 newtons. So we have 50. Final velocity is 15. And initial velocity is the one that we have been calculating earlier on. So the answer that you get there, you bring it here, you divide that by 2. Then once you do that, even if this answer is wrong, you don't have to worry. You can still bring it here. Make sure that you write it as it is. Then when you substitute it in here, then you get your full marks for the formula as well as for the substitution. Right. Let's have a look at another one, so that guys we familiarize ourselves on this process. Right. Let's have a look on this question. That is question 7. Right. Question 7 is saying we need to go through and check what is happening on question 7. Right. On this question 7, calculate. Right. That is the main thing that we need to check, and that is what we need to know. Right. Let's have a look on that one. Fine. We need to calculate the magnitudes of the unknown charges. Fine. How do you know which section to go? This is electrostatics. So if we go through onto the formula sheet, there is our electrostatics. Right. This question is saying calculate. We are dealing with forces here. We are dealing with forces. If we check this one, electrostatic force, that is what is given, electrostatic force. So our formula for force will be that one. Right. Let me write the formula down now. This is 7.2. Right. As we read through the question, calculate the magnitudes of the unknown charges. So firstly, copying the formula straight from the formula sheet. Q1, Q2 over R squared. We have a mark already. Right. Let's see what is wanted now. At first here, we are given the net electrostatic charge of which is experienced by charge 3 due to Q1 and Q2, right? The second one, we are given the force experienced by Q1 due to Q3, which is that. Fine. So this one is easy for us to start with because we are given the force. We substitute 0.012. That is the force given. This is equal to K is a constant that will be provided on your formula sheet. That is 9 times 10 to the power 9. The one we want to calculate is the unknown charge Q1. So we don't know our Q1, but Q2, we know it. Q2 is 2.0 times 10 to the power minus 6. So since we deal with magnitudes here, we just write it as 2 times 10 to the power minus 6. Then everything over our distance between Q1 and Q3 is 1.5 plus this one. That gives us 2.5. Then you have to square it. Once you've done this, this is your formula, and you've done your substitution, then you get your answer, right? Then the part 2 of the question now. You are given your net force, which should be given by your force on charge 2, force of charge 2 on charge 1. We subtract force of charge 1 on charge 2. Now, the net force is given here, that is 0.3. Let's take left as positive. Now, this is equal to force of 2 on 1. The force of 2 on 1 is what we have calculated here. So we need to bring our answer, the answer that we have calculated here, we bring it there. When we get our answer, let me just say this answer is X. So we are going to bring our answer here. Then we subtract this one that is given, which is 0.012. Then from there, we can find our this. This is our thing. Right. Then from there, when we get our answer here, which is going to be an addition of this and that. Okay, fine. Let me not go much into details of calculations. I'm only after the formula and the substitution for us to get the easy marks. So basically, we'll now come back for us to calculate the charge of Q2. We'll come back again to the same formula. F is equal to K, Q1, Q2 over R squared. Then now, here, F is the answer that we get here, which is, let me indicate it like this, which is now what you need to take. The answer from here, you plug it in there. Then your answer, let me call that Y, is equal to K. K, I've told you it's a constant. Let me do this so that I can have space. Okay, fine. So Y is equal to K, 9.0 times 10 to the power 9. Then Q2 is what you want. We don't know it. And Q3, we know it's 2 times 10 to the power minus 6, like this. Then everything over the distance between the two is 1 meter over 1 squared. So now you have another mark for the formula, another mark for the substitution. Then you will get your answer for getting those ones. Right. Oh, good. Right. Let's have a look on another question, which is on electric circuits. Right. The question is saying, calculate the current in the 8 ohm resistor, calculate the equivalent resistance of the resistor in parallel, internal resistance, heat dissipated in the external circuit in 2 seconds, All these questions, they basically need us to have some formula and substitution, which are the easy marks we are concentrating on. Start with 9.2.1. Right. Current in the 8 ohm resistor. This is the 8 ohm resistor, and a voltmeter connected across the 8 ohm resistor reads 21.84 volts. Right. Let's have a look on our formula sheet. We are 9.2.1. We are required to calculate our current, and this current is across an 8 ohm resistor with a voltage of 21.84. The resistor itself is 8 ohms. Right. Let me make it an R like this. So the formula that we can have is that of the Ohm's law. Resistance is equal to voltage over current. Our resistance is 8. The voltage is 21.84. Right. Over the current, which is what we are required to calculate. Right. This is a simple thing where your formula plus your substitution, you already have scored your 2 marks out of 3. Right. Let's have a look also on the next question, which is calculate the equivalent resistance. So for us to calculate the equivalent resistance of the resistors that are in parallel, let's go to the formula sheet. Right. How do you calculate resistance for resistors in parallel? This is the formula, which is 1 over Rp. That's how we calculate the resistance for resistors in parallel. So you write down 9.2.2 and copy your formula correctly from the formula sheet, which is 1 over Rp equals to 1 over first resistor plus 1 over the second resistor. So in this case, our resistors in parallel is this and that one. So now substituting into the formula, that is 1 over the first resistor is 30 plus the second one is 20. Simple and nice, right? So for our formula plus our substitution, we are going to have all our marks there in, right? So now you need to punch this into a calculator and you get your answer. Let's have a look again on another question, which is now 9.2.3. Calculate the internal resistance of the battery. Right. Let's say go to the formula sheet. The only formula which is having internal resistance small r is this one. So we need to write down the formula as is from the formula sheet, which is EMF is equal to I R plus the small r, which is what you want, right? If you go through the question here on the first line, 60 volts is the EMF. Now we substitute 60 volts. Current, we have been required to calculate the current here in 9.2.1. So the very same current that we have calculated 9.2.1, that is the current which is needed here. So if I may just provide it for you, let's say that current is 2.73. Right. This is just an example. So this is the current that we have calculated here in 9.2.1. That is what I'm saying, it's 2.7.3. Right. Now, this is the one that would need to correctly substitute it there. Don't worry if either this is correct or wrong, but make sure that you correctly substitute it there, right? Fine. Then our resistance, the resistance here, we are required to calculate the equivalent resistance from question 9.2.2. So I'm just giving it to you. Let's say that equivalent resistance here that we got, that is 20. Right. So we need to take our 20, we substitute it there, then plus R, that will give us our well substituted value. So what you need to do now is if you arrive on questions like this one, which is 9.2.3, what you need to know is check from the earlier questions that you have done. What other necessary information do you need to make use of at this stage of your calculations? So at this stage, we have substituted, we have written our formula, and we have done our substitution there. Right, let's have a look on the last part of the question, which is this one of 9.2.4. Right, there's our formula sheet. I'm writing 9.2.4. Fine. Heat dissipated in the external circuit. We want heat. Heat is given in joules, so we need to use this formula, that is work. Work is measured in joules, so the heat that is being dissipated is the work done by the circuit. Right, what do we know about the circuit? We have calculated the current here, we have the resistance, we also have, this is the internal resistance. So we need to have a look on what other information do we know. Fine, we use this formula, which is work is equal to I squared R delta T. Why did I choose this formula? Fine, this is how I choose it. I want to calculate heat, which is W, work done by the rest of the circuit. Right, current, I've calculated the current in 9.2.1, so I know the value of the current from 9.2.1. Let me just guide you by this. That is the current that you've calculated from 9.2.1. Right, the resistance is what we have calculated from 9.2.2. I'm just teaching you guys to say, if you are given this formula like this one, when you're on a question like this, check the information that might be helpful to you from the previous questions like 9.2 and 9.2.1. Right, then from there, your time, that is time, it is given in the question 0.2 seconds, that is 0.2 seconds. So then now from that one, the answer we get from 9.2.1, we substitute it there. The answer we get from 9.2.2, we substitute it there. And the answer, the time is given in the question, we substitute it from there. So now you get your marks for your formula plus for the substitution that you have done. Right, let's have a look to see. Now, for only the 4 questions that we have done, only choosing the correct formula plus the basic substitutions, we have scored about 14 marks only on 4 questions, right? Let's have a look, which is giving us 45 marks altogether from formula, the substitution, free body diagrams, plus simple definitions. One is already at 45 marks altogether. Right, let's have a look, which gives us 30% already, only for 4 questions, knowing definitions, the formula, substitution, plus free body diagrams. But that does not end there. We are also having some good news for you guys. What are the good news for? Right, there are a whole lot more of questions for us to look at. Let's have a look at question 2. At question 2, there are also some simple marks that one can get. Some easy 6 marks here. Calculate. When you calculate the normal force, you need the formula, you substitute also for that one formula, then you substitute, calculate the acceleration, formula and substitution. There are 6 easy marks there. Also, on another question, which is this one on momentum, if the question is saying calculate, there are also some easy marks that one can get, some 2 easy marks for formula plus the substitution. Not only on that one, let's have a look on another question. This is Doppler effect. There goes calculate. There are also some 2 easy marks for the formula plus the substitution. So these are some easy marks that one will be collecting, pocketing, passing made easy. Right, on that one also, calculate the magnitude of the net electric field. Some 3 easy marks which one can collect from there. Also this one on electrodynamics, we are also required to calculate it there. There are still some easy marks, some 2 easy marks which one can get. Not only there is this one on photoelectric effect, which is basically the last question of the paper, which one can easily score some 3 easy marks there. Thank you guys. Wish you the best. One can easily score 63 marks. Only so easy. Good luck.